Welcome. In this lesson, we are diving into one of the foundations of classical physics, translation motion kinematics in one direction. This is all about how objects move in straight lines, whether it's a car on a highway, a ball rolling down a ramp, or even an apple falling from a tree. Let's explore the language of motion. In physics, translation motion means movement from one point to another as opposed to rotating or spinning. When we limit this motion to a single straight line, we are talking about one-dimensional motion. Let's start with the basics, the key quantities. First up, position. This tells us where an object is along a straight path. We usually represent it with the variable x. Positive x values might be at the right of the reference point and the negatives to the left. Next is displacement, not to be confused with distance. Displacement is a change in position. It's a vector, meaning it has both magnitude and direction. For example, moving from x equals to 2 meters to x equals to 5 meters gives a displacement of plus 3 meters. Now let's talk velocity. Velocity is the rate of change of position with respect to time. In one dimension, it's simply v equals to delta x by delta t, where delta x is the displacement and the delta t is the time interval. Positive velocity means motion in one direction, say right, and the negative velocity means motion in the opposite direction. When velocity changes over time, we have acceleration. It's defined as a equals to delta v by delta t. Like velocity, acceleration in one dimension can also be positive or negative. A positive acceleration means an increase in velocity in the positive direction, or a decrease in velocity if the motion is negative. It all depends on the frame of reference. Now we are ready for the kinematic equations. These are the mathematical tools we use when acceleration is constant. There are four main ones to know. This gives final velocity after time t. This calculates position based on time. A time independent equation great when you don't know t. This gives position using average velocity. These equations help us predict how objects move under uniform acceleration like gravity. Let's apply them. Suppose you drop a ball from rest. Gravity gives it a constant downward acceleration of 9.8 meters per second squared. Using the second kinematic equation, we can find how far it falls in any amount of time. X equals to x naught plus half gt squared. Since it starts from rest, v naught equals to 0 and x naught equals to 0 after 2 seconds. X equals to half multiply 9.8 multiplied by 2 square equals to 19.6 meter. That's the power of kinematics. We can predict the future of motion. So to recap, one-dimensional translation motion deals with position, displacement, velocity and acceleration all along a single axis. When acceleration is constant, we use the kinetic equations to describe and predict motion. Master these and you unlock the first key to understanding the entire universe of motion. Thanks for watching. In the next video, we will talk these concepts into two dimensions, adding a whole new layer with vectors and projectile motions. See you there.